The Fourdrinier table consists of an endless moving belt on which the fibers form into a sheet when the water is removed by gravity and suction. The forming wire or fabric itself is a finely woven, continuous belt made of polyester monofilaments, phosphor bronze, or metal. The mesh allows the water to drain while retaining the fibers. The weave pattern, mesh, and yarn diameter are all selected to suit the grade of paper being made. The wire travels between two large rolls, the breast roll near the head box and the couche roll at the other end. The various elements between the breast roll and the couche roll support and move the wire as well as help drain the water. Most machines today utilize a forming board immediately after the breast roll. At this point, the stock consists of about 1 or 2% solids and around 98% water. From the forming board, the wire passes over a number of foil assemblies and table rolls, followed by a series of vacuum devices, from low vacuum wet boxes to high vacuum dry boxes. The roll in between these boxes is the dandy roll, which is sometimes used to make the sheet more uniform. From there, the sheet passes over the high vacuum couche roll before it is lifted off the wire by a press felt. The sheet is now about 20% solids and 80% water. At this point, we usually trim off a narrow strip from each edge as the sheet leaves the couche. The edges are usually weak and may cause breaks. This cutting is performed by high-pressure water jets called squirts, located over the wire just prior to the couche roll. A system of wire return rolls carries the belt back to the breast roll while the sheet continues on to the wet pressing section for further consolidation. The power that drives the Fourdrinier wire is usually applied to the couche roll and to the wire turning roll. As soon as the stock settles on the forming wire, it begins to drain. At this point, it is 99% water. By the time the stock reaches this point, which takes just a few seconds, it will contain less than 80% water. In order to accomplish the removal of literally thousands of pounds of water, we use a series of drainage elements, such as foils, table rolls, and vacuum boxes, together with hydraulic pressure. Basically, drainage on the Fourdrinier wire is accomplished by the drainage elements along the wire. In the free drainage area, the degrees of pressure, or gradients, are produced by hydrodynamic suction forces as the wire passes over either rotating table rolls or stationary contoured foils. Further down the wire, various vacuum devices are used to remove additional water. These are assisted by pressure from a dandy roll or lump breaker roll on some machines. The first drainage element under the wire is the forming board. It is a stationary flat board directly under the slice that supports the wire at the point of jet impingement and therefore takes a heavy load. Generally, the forming board serves to retard initial drainage so that fines and fillers are not washed through the sheet. However, the length and open area of the assembly must be compatible with the grade requirements and machine speeds. For these reasons, this board must be fabricated to exacting standards. After the forming board, the next drainage elements are a series of hydrofoils and table rolls. Neither has vacuum devices. However, vacuum action does occur by hydrodynamic suction forces as the wire travels rapidly over them. The primary difference between foils and rolls is that foils are stationary and table rolls are not. The suction produced by the table roll is due to the separating of the roll and wire surfaces, both of which are moving. However, when the wire passes over a foil, which has an angled stationary surface, the suction produced is less because only one surface is moving. The water that drains from the first part of the table is collected in trays which lead to the whitewater recovery system. Further down the table, we use vacuum-assisted foils or wet boxes to drain more of the water. And after that, we increase the vacuum to drain as much of the water as possible in what's called dry boxes. In some mills, these drainage elements are assisted by pressure from a dandy roll or even a lump roll. As the sheet moves over the flat box section, the water becomes increasingly more difficult to extract. That's why we have to use progressively higher vacuum levels as more and more of the water is removed. Now that you've seen the elements of the forming table that help drain the water, let's take a look at what is actually happening to the sheet. As soon as the stock touches the forming wire, it begins to drain. Since it is more than 99% water, drainage is fairly fast. Two events immediately take place. First, the fibers tend to coagulate, and second, they form a mat on the wire. The important thing for you to remember in all of this is that in each design of a commercial sheet forming machine, whether twin wire or Fourdrinier, we apply the three elementary forming effects of drainage, oriented shear and turbulence in different degrees in order to get the best sheet quality that we can. After we have dewatered the forming sheet as much as we can on the Ford veneer, it is lifted off the wire just after the couch roll. From here, the sheet is further consolidated and pressed in the next section of the wet end of the machine.